Hi class. For this recording, we're going to deal with two different types of problem-solving situations. The first one is going to be one where we're going to learn how to use an organizational chart to help us set up our problem. Now, for this particular one key thing to know that you're going to use this table is that you're dealing with two different things that have two different percentage amounts. In this case, you're investing money into two different accounts that earn different interest. This also works if you're dealing with chemistry solutions where you're mixing two different things that have a different percentage of the solution. So you can use the same thing with those. You'll also notice that in these problems, you're going to have two different total amounts. For instance, for this particular problem, we have invested $15,000 into two accounts. So we have a total of $15,000. One account's going to earn 6%, the other account earns 8%. So notice we're mixing two things with percents. And then we have another total, which is the total interest earned for the year, which is $1,000. So you'll notice that we have two totals, the $1,000 and the $15,000. Sometimes the second total you can get by doing a multiplication of a percentage times your first total. But in this case, notice that we were given two totals and we were given two percentages. That's a key that this table may work to help you organize your information. In the table, the third column is always the total column. And so we have two totals. We have $15,000 that is invested. So I'm going to fill in this box with that $15,000. And then the other total is the interest earned for the year, which was $1,000, which I'm going to put in this box. Notice that I have the word total in the first box of this column. That's because this first row here is always your labels of what each column is going to represent. Then below it you give values. Now, since this total is the total money invested, this row is going to represent our money. Since this total here is the total interest earned, this row is going to deal with our interest that we earn on each account. Now, what do we do with the other two columns here? Well, we have two different accounts, so let's label one column for one account, which was a 6% account, and the other column for the other account, which was an 8% account. Now we know what each of those columns is going to represent. Now, for this row here, since this is money, we don't know how much money is in the 6% account, so we're going to give it a letter. Let's call it X. We also don't know how much money is in the 8% account, so let's give it a different letter. Let's call it Y. Now, as far as interest, since it's simple interest and it's only 1 year, we can get the interest by taking the percentage times how much money was in there. So to fill in the interest for this box here, I would take the 6% times the X, which is going to be 0.06X. Similarly, in this next box here, I'm going to take the percentage of 8 times the Y, which is 0.08y. In this setup, you will always do this first value here times this next value to equal the bottom value. And also in this table, you always have first column plus second column equals third column, which makes it so we can get two equations, one off of this row, which is going to be X plus Y equals $15,000. And one off this table, or row of the table, which is 0.06x plus 0.08y equals 1,000. Now, notice that we have two equations here. And both equations have two variables. We don't know how to solve anything with two variables. We only know how to solve something with one variable. So what we're going to do is a little process that uses our information we learned about solving for a variable in an equation in order to create from these two equations here an equation with only one variable. This first equation would be very easy to solve for a variable in. We'd just either have to subtract x or subtract y from both sides. So what we're going to do is just choose which one we're going to solve for. I'm going to solve for x. To do that, I have to subtract y from both sides of the equation. That makes x equal to 15,000 minus y. Since x is that, and x is the same in both equations, I can take this and replace the x in the other equation with it. What that does is it gives me 0.06 times 15,000 minus y plus 0.08y equals 1,000. And that is something that we can solve because there's only one variable. So we used this table here and these two equations just to help us organize ourselves so we could come up with something that we could use and knew how to solve. Now we just need to solve it. So let's distribute our 0.06. 0.06 times 15,000 is going to be 900. 0.06 times negative y is going to be negative 0.06y. And then we'll copy the rest down. Now let's combine our like terms, and combining these I'm going to get 0.02y plus our 900 equals 1,000. Now we're going to go ahead and move our 900 by subtracting 900 from both sides. These cancel and I end up with 0.02y equals 100. And now if we divide both sides by 0.02, we will find out that, and I'm going to write it over here, I ran out of room, y equals $5,000. So that means that we invested $5,000 into this account, and if we only had $15,000 to invest, there was $10,000 left for this account. So that is one way to deal with solving this. This is different than what you will find in your book, but it also helps you get set up for your next class, because the next class you will be solving things that are similar to this. Now, that's the one where organizing yourself in a table will help you out. Now, some situations will be nice for drawing a picture to help you set up your problem. So let's say that you have a problem where you have two cars leaving the same place at the same time in opposite directions. One car is traveling at 55 miles per hour and the other at 60 miles per hour. When will the two cars be 230 miles apart? Now, for this particular problem, we are going to be using a certain formula. And that formula is your distance formula, which is distance equals rate times time. Now, a picture of this situation is going to help us set this problem up. Now, we're going to assume there's no stoplights or stop signs or anything, so they're going to be able to just continue driving at that rate for as long as it takes to be 230 miles apart. So let's set up a picture for this situation. Here's your starting spot. The two cars leave in opposite directions. So you have one car going this way and one car going this way. Let's say this car is the 55 miles per hour car, and this one is the 60 mile per hour car. Now we want to know when this distance for where this car is and this car is 230 miles. Now, we need to think about this. They're going to travel for the same exact time. So, time in this equation here will be the same for both of them. The distance for this car here will then be the rate, 55 miles per hour, times how long it has driven, which would be 55t. Similarly, the distance for this other car here is going to be its rate of 60 miles per hour times t, and t is the same for both cars because they left at the same exact time. So, you can see from this picture that this 55t here plus the 60t is the same as this 230 miles. So that gives us an equation of 55t plus 60t equals 230. All we have to do is solve this equation and we'll have our answer. Combining our like terms, we get 115t equals 230. Divide both sides by 115, and we find out that t is 2 hours. So that's how long it took us to get those two cars 230 miles apart. So in this situation, we're using the formula distance equals rate times time, and the picture helps you set up your equation. So now you have two more strategies for solving your problems. You can use a table to organize your information, or you can draw your picture.